Hi, I'm Neil Dixon. Welcome to the 5th video in this tutorial on assembly language. Last time we looked at the stack, and this time we'll briefly see another way to call functions with it. We'll also see Inventor IDE Alpha 5, and a preview of what we'll be doing in the rest of this tutorial. Last time we saw the so-called standard calling convention. All this really means is that parameters are on the stack, and the function being called is responsible for clearing parameters from the stack, using the ret instruction with a constant as an operand. We used ESP and EBP to keep track of the stack. However, there are other calling conventions, one of which is called the C calling convention, and it is commonly used by compilers doing a release build. With this convention, the parameters are still on the stack, but the calling code is responsible for clearing the parameters from the stack. There are many ways of doing this, but most don't use EBP, so it's then free to be used for other purposes, giving us 7 general registers to use for anything. Some variations on the C calling convention keep space on the stack for all possible parameters passed by the current function to called functions, meaning that they only need to be cleared once, even if 50 function calls occur. This can save a lot of time, and allow us to use move instead of push to set parameter values. So why would we ever want to use the standard calling convention? The C calling convention can be much harder for debuggers to unravel, because they need to rely on simple code to figure out the size of each stack frame. That's why compilers doing a debug build often use the standard calling convention, where the saved EBP values mark the stack frames. Let's look at an example of calling and returning from a function with this version of the C calling convention. The space for parameters is already reserved on the stack. In this example, some function called from the current function takes 4 parameters, but we're calling one with just 3. So, we only need to fill in those 3 parameters, which we can do with move now. Now we call the function myFunction, which puts the return address on the stack as before. Now the total size of local variables in myFunction, plus the maximum size of any parameter list passed inside of myFunction, is 24 bytes in this example. So we can simply reserve 24 bytes on the stack by subtracting from ESP. We can refer to parameters and local variables in terms of ESP instead of EBP. Then myFunction executes, and when we want to return, we clear this parameter and local variable space from the stack by adding to ESP, and then return. Now we're back in the previous function. Note that when I say clearing off the stack, the data could still be there in memory, but it can't be relied upon to be the same. This has to do with that the operating system could interrupt our code at any point, pushing data onto the stack, and we wouldn't know it. So when you first run Inventor IDE Alpha 5, if you hit the Run button, this is roughly what you'll see. You'll have the original image on the left, and the image produced by the drawImage function on the right. Now, if we do something to it, such as what we did in the first tutorial, filling it with color, you'll get this result. Again, showing the result of the operation on the right. Now, what we'll be doing in not too long is some much more interesting stuff. So this takes the image on the left, does a Gaussian blur on it, and some thresholding to figure out where the orange paths are and the red blobs are. You'll see why that's interesting later. We'll be doing some neat stuff with it. In the next video, we'll be cleaning up the noise in the tunnel map photo using a Gaussian blur. Thanks for watching.